morning all. So in the last session we have seen what is relation, how to draw the diagram if relation is given, okay, and what is matrix representation of relation, what is R square relation, what is RS to infinity relation, okay, etc. Now in this session we will see one important theorem for 5 marks, very important theorem. They ask this question many times. If you see your previous question papers, this question arises many times, okay, maximum number of times. So this theorem is little bit theoretical. It is difficult to understand for you because it is difficult to understand for our BSc students only. So I can't accept from you. So if you are getting difficulty, only by heart this theorem and write down in the exam. That is only possibility for you, okay. So here we have, if R is a relation, you know what is a relation first. If R is a relation on a set A is equal to, here set A is given A1, A2, so on AN, then we have to prove MR square is equal to MR dot MR. MR means matrix representation. This is the notation of matrix representation of this relation R, okay. So we have MR square is equal to what? MR dot into MR dot. We have to show this. So for that, let us take C. In generally, we denote the matrix A is equal to what? AIG. Already I have explained this. In generally, matrix A is denoted as AIG. Means, for example, in general, A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the matrix of order 3. This is the general representation. Okay. So A11 means first, this element representing first row, first column. These are the rows: first row, second row, third row, first column, second column, third column. A12, first row, second column. A22 or A32. So 3 means first row. Okay. So third row, we have to consider first number for row, second number for column. So third row, second column. Okay. So A32 means third row, second column. So in general, we denote matrix A is equal to Aij, where I is the row, J is the column. So ith row and jth column. This element present in generally ith row and jth column. Okay. So here let us consider MR is equal to MIJ. Okay. And MR square is equal to NIJ. Let us denote this is the notation for this, and MR square is the NIJ is the notation for MR square. Then by definition, ith row, okay, ith row and jth column. For just I have got 832 means third row, second column, like that. Okay, so in generally ith row and jth column of this matrix MR dot MR. Okay, by definition ith row and jth column of the matrix MR dot MR is equal to 1. Is equal to 1 if and only if same ith row and jth column of MR have 1 in same position. Okay, see, because if you have MR dot MR, okay, so if in your MR matrix, if you are having 1 in one position, then this matrix contains 1 in same position if their ith row and jth column of MR have a 1 in same position. Okay, then let us denote that by K. Let us denote that by K, where K lies between 1 and n. Lies between means the value of K is greater than or equal to 1 and it is less than or equal to n. Okay. Therefore we get MIK is equal to 1 and MKJ is equal to 1. So in relation we denote it is AI related to AK, because here we have ith row, K column. So AI related to AK. Using this we can write AK related to AJ. Now see, here we have AI related to AK and AK related to AJ. So as I said in the R square relation, there we want two parts. So first we have AI to AK, AK to AJ. So we can write AI R square related to AJ. Because for example, see, we have AI to AK. Let us see, this is our KJ. So we have AI to AK, then AK to AJ. Okay. So for this here we have this from one part, this is the second part. So we can say I and J are R square related. So we can write AI R square related to AJ. But R square relation means this matrix. Okay. So AI R square related to AJ, then the value of Nij is also in the same position of this. Okay, because AI R square related to AJ is the R square matrix. R square related matrix means Nij is equal to 1. Now from this we have Nij position is also same and Mij position is also same. So we can write Mr square is equal to Mr dot Mr. See, this is the theoretical. I know you will get difficulty to understand. So for your only by heart this theorem and write down in the exam. Okay, because this is little bit difficult and theoretical. So by heart this theorem and write down in the exam, because this is very important theorem. I don't know why they give this theorem for your syllabus, because there is no use for this. But if they ask, please by heart and write down this proof. Okay, so this is about the theorem. Next we have next concept is partition of a set. Okay, so what is the partition of a set? Suppose if A is a given set, then collection of all non-empty subsets. You know what is subsets? So collection of all non-empty subsets are called partition if it satisfies two conditions. First, union of all the sets. Or suppose if A1, A2, A3, so on are the subsets, then union A1, union A2, union so on, union AN should be equal to the given set A itself. And second one, the intersection A1 intersection A2 intersection so on intersection AN should be equal to empty set. If these two conditions satisfied, then we can call A1, A2 so on AN are the partition of the given sets. Okay, where A1, A2, AN are the subset. First it should be subsets of A. So how to find the partition of set? If A is given, find all the possible subsets. Suppose if A is given, find the all possible subsets of A. Okay, then take the subsets which satisfy these two conditions. Means if you are taking union of that set, then it should be the given set itself. If union and intersection. If you are taking intersection as common elements. If you are taking intersection of that sets, then it should be empty set. Okay. So for example, suppose if you are having A is equal to 190. Okay, if you are having A is equal to 190. First write down all the possible subsets. So first subset is the singleton set 1. Next A2 is equal to the singleton set 2. And A3 is equal to the given set 1, 2, etc. So only these three subsets are an empty set one more. Okay, so four subsets are possible because if we are having only 1, 2. So we have A1, A2, A3. Now among these three sets, take those sets which satisfy these two conditions. Okay. So if you are taking A1 and A2, see, we can write A1 union A2 is equal to what? 1 union 2. And what is the 1 union 2? 1 comma 2. 1 union means the elements which belongs to either this set or this set. So 1 comma 2. And 1 comma 2 is the given set itself. So A1 union A2 is the given set A itself. Okay. Now check the intersection. If you are taking intersection, so you will get A1 intersection A2 is equal to 1 intersection 2. Intersection means we want common element, but there is no common element from 1 and 2, so this is empty set. Now see, it satisfies both the conditions. First A1 union A is equal to the A set itself, and A1 intersection A2 is equal to what? Empty set. Okay, so it satisfies both the conditions. Therefore partition of the given set, partition of the given set is A1 comma A2. A1 comma A2. Okay, denote like this. A1 comma A2. So partition of the set is A1 comma A2. We can't take A3 set itself because if you are taking these two sets, you will get first condition is satisfied 1, 2. But if you are taking second condition intersection, you will get common element is 1. But we want it should be empty set. So similarly, if you are taking these two, again it will satisfy first condition, but the second condition is 12 because you will get common element is 2. So only these two sets. So partition of set A is denoted as A1 comma A2. Okay. So this is the partition. I will solve one more example. Depend on the partition. partition of the given set. Okay. So we have one more example. If A is equal to if A is equal to A, B, C, then find the partition of the given set A. Okay. So first find all the possible subsets of A. So you will get first A1 is equal to singleton set A. Next you will get A2 is equal to singleton set B. Next you will get A3 is equal to singleton set C. Next you will get A4 is equal to the pair AB. Next A5 is equal to the pair BC. And next A6 is equal to the pair A comma C. And finally the last set A7 is equal to A, B, C. So these are the possible subsets of the given set, right? First we have to write the singleton set. Next we have to take the pair sets. Okay, two numbers. So A, B, B, C and A, C. Now we want the partition. So first partition we will get. See here A1, A2, A3. So we can take A1 union A2 union A3. So A union B union C. So you will get the set A, B, C. So set itself, that is A itself. Next, intersection. So A1 intersection A2 intersection A3. So A intersection B intersection C. So there is a no common element from these all three sets. So this is empty. So this satisfies the first condition. So first partitions are, therefore partition is, if you denote P, first A1 comma A2 comma A3. Okay, this is the partition A1 comma A2 comma A3 because these three sets satisfy this condition. We can find again more partitions here. If you take, see, by saying this only we can see if you are taking A and AB, we get A is common. So don't take. If you take A and BC, A and BC. So here we have A1 and here we have A5, union A5. So singleton set A, union singleton set B, C. So you will get this is equal to what? A comma B comma C. Again the set itself. Then take intersection A1 intersection A5. So in the set A intersection the set B comma C. If you see again we don't have any common elements from these two. So the value is empty set. Okay. So again the next partition is, we can find many partitions from using one set. A1 and A5. Similarly, if you see here we have A2 is B and here we have A6 is AC. So if you take the union of these two, you will get A, B, C. If you take the intersection, there is no common element from B and this A2 and A6. So you will get empty. So it satisfies the condition. So similarly, you will get the next partition is A2 comma A6. Similarly, you will get one more partition here. See, A3 is C and if you take A4 is AB and if you are taking union of these two, you will get ABC, and if you are taking intersection, there is no common element from these two sets, so you will get empty. So you will get next partition is A3 comma A4. So these are the possible partition of the given set A. If you check for other, you can't get, because if you take AB, if you are taking this A4 and A5, we will get common element is B, but we don't want any common element. If you are taking these two, you will get common element is C. If you are taking these, you will get common element is A. Okay, so it is not possible. So only these are the partition of the given set A. Okay, so this is about partition. So we have last concept, that is pigeonhole principle. So we can see that in the